Здравейте пак. Това е Merlijn, който ще говори за Rubbernose, който е една файлова система с plausible deniability, който иска да прочете, ако не да слуша хубаво. And you're ready to go.
Thank you. Okay, thank you everyone for coming here. I'll be talking about Rubbernose. I won't be filling the full 25 minutes because I want to leave some room for questions because it's nice to have some open questions and ideas session for like 5 or 10 minutes. Okay, so Rubbernose is a continuation of a project originally done by Julian Assange from WikiLeaks. That project was called Rubbernose. Right, should be here. It's a plausible deniability file system. It's a mouthful, but basically it means that you can put a file system on your hard disk and then police or nasty people, terrorists, they will not be able to show or they will not be able to see what if certain stuff is on your hard disk. So you can deny that you have a certain picture of leaked documents that shows that the government is assassinating people or they're holding people secret, or you just really don't want to share your pie recipe, that's fine. So the idea is that you can have any number of partitions, and no one will be able to show how many partitions there are on the hard disk, and you can also not prove that you've actually unlocked all of them. Okay, so the original idea was by Julian and 2 other people. It was really written for Linux 2.2 and I think a very old variant of NetBSD. It's now unmaintained and has been for like 10 years. They made it very complex, so it was composed of a few kernel modules, some user space programs that communicated together, and the file system, so it was not very usable and very hard to use. But they had some very nifty features, like if you haven't been at your machine for more than 10 minutes, then unmount everything so you can't show that it was ever mounted. Okay, so the idea is that you can plausibly deny the existence of something. I think I covered this, so... all right, so the original idea was, I started working on this because I'm from the Netherlands, and they were proposing a law that would make you guilty until proven innocent, which is in a very contrast of, well, law. And the idea was that they could force you to give up your encryption key even if you didn't do anything wrong. So if they suspected you were doing something wrong, you'd have to give up your key. And if you didn't, then you'd have to spend 3 years in jail, even if you just had an encrypted partition with some vacation photos and some music. So that's pretty terrible. And the law hasn't passed yet, but I think they'll be quite successful because they've done the same in the UK already. They can hold you pretty much indefinitely, even if they suspect you of having some bits flipped in some vacation picture, which you could extract some information with. It's called steganography, I think. It's a difficult term. But it's a different way of hiding information. But basically it is the same. If they can't prove that you have something, but they suspect you have it, then they can keep you, which is really weird. So the idea was to make a system in which you can plausibly deny that you don't have it, which means, hey, there's lots of data on here, but yeah, there's no other data, and yeah, I just can't unlock it, sorry. So the theory is doable. I'll try it. This better? This is better. Okay, so generally if you have a hard disk, it's just, let's see, it's a continuous block, and there's lots of sectors which you can write. They start at 0 and you go to some number. Numbers increases as the hard disk grow larger because you can write more data on it. And typically you can partition it into a few large blocks. On Windows you can have a C drive and a D drive. On Linux you can have a root partition, maybe your home partition. Those are usually separate blocks, but you can do some magic in the kernel. But basically the idea is that in this case we will spread the data all over your hard disk and it will be encrypted. So if you allocate some partition, it won't be on a specific block, it will be spread all over the hard disk in very little bits. So if you want to perform a file system out of this, forget it. It will be very slow, but hey. And the starting point of each partition is only known to the user. And if you know where your encryption starts and you know the password to decipher it, then you can unlock the partition. And no one else knows this. And typically we want to use some password to actually find the first partition, so apply some funny functions to the password to find a number, and that's where your partition starts, and then you can fill an additional password, and if it all matches, then you can unlock the partition. And the idea is that if everything is encrypted, like everything, then you can't distinguish it from random data, which means you can have a hard disk filled with random data and they can't see that there's anything on there, and there's no difference between you storing a lot of information in there or it just being completely random. And note that some systems, like if you encrypt the hard disk, then they already advise you to fill it with random bits, but it's still quite different because, for example, most people on Linux still will use LUKS, L-U-K-S. It's a very nice system for encrypting stuff. It will allow you to change passwords and so on, but it stores all the metadata in unencrypted text. So it's not very useful if you want to plausibly deny everything. But we will be using LUKS. We have a few tricks for this. So what we will be doing is we will be using existing stuff in the Linux kernel. There's this thing called device mapper, which is also used by the LUKS standard and decrypt. So basically it allows you to map a certain block on a hard disk to another block, and in the mapping do some funky stuff. You could flip bits, or more usably encrypt everything. Or you could say, I have this large block and I want to make smaller blocks out of it, and you can do it in the kernel as well with the device mapper. So the reason to do this is in Linux, I mean with the existing code base, because it will simplify your implementation a lot. And we hope to get it into the kernel at some point. Okay, so the idea is that we will start with the hard disk, and from the hard disk we will make a new block device, in this case our own, and there will be lots of small block devices on there, encrypted, and the encrypted part will store the LUKS metadata, which will then point to another block on the hard disk where we actually store the LUKS data, and this is all spread over the hard disk, so randomly, or semi-randomly, because you will be able to need to find it. So the only data we need is the LUKS data, which contains how your stuff's encrypted, plus a few initial data points which says, hey, here's where our data starts, and this is how we'll get it back. So you can imagine that will be trivial. And then it will be a device mapper kernel module, which is, again, using the existing infrastructure of device mapper. And then you can load it like all the other device mapper modules, use it with the same user space scripts, and that will just work. So so far this is a theoretical model of, and practical as well, of implementing plausible deniability, but there's a lot of problems here because, for example, if you run locate, which is a tool that will index, mlocate, it will index all your files in your hard disk. And if you unlock everything at home, you're drinking a cup of coffee, then you're going somewhere else. And you give up your one of your systems which contains the locate database, and everyone can see what all the files on your partitions were, which is really stupid. And this is just one example. There's plenty of examples like this. So there's quite some caveats to actually doing this. So one of our ideas was to make each aspect or partition just a virtual machine, which is just the image of your virtual machine, which doesn't know anything about the others. And then you can actually make sure that no one else can see what you're doing. But this will be optional, because it's still nice to have this way as well if you know what you're doing. Okay, so a future plan is to have this in the kernel, and that will be really nice to increase the plausibility of plausible deniability. Because if everyone has it installed by default, then it makes more sense to say, well, yeah, well, this is just some random data, or I just have one partition, or yeah, the installer told me to do this, so I just did it. And I mean, if there's just one person in the world using this, then it's not very likely that you can plausibly deny that you are in fact not hiding something, so to say. There's a few other things we want to do. I already mentioned the virtual machine thing, so you can have a small virtual machine on each aspect, so they're shielded from each other. But we also want to implement block swapping. This is something Julian also did in this project, or planned to do, I'm not sure. The idea was that if you read and write to the same blocks all the time, even though they're randomly mapped, they'll still be on the same place because you're not moving them, typically at least, unless you delete a file or something. And if you do it often, then you can see which parts of the hard disk were used, and if they're used very often, then they can say, yeah, but you claim this is random data, but you've written a lot to this part, so what's on there? And this is actually really hard to do in practice for the police or any investigator, because it's not very viable, but it's possible. So we want to make something that will automatically move the blocks every now and then. So just make sure they're not at the same place all the time. And yeah, it would be nice to have some kind of auto unmining feature, but that would just be some bash script or anything, something simple. Okay, some credits. I came up with the idea to do this, and some other students picked it up and they wrote a small paper on it. I don't have the reference here right now, but if you want it, I can give it to you. And some friends at University of Amsterdam, and a few fellow hackers of my. I'm a member of the hackerspace in Amsterdam, and a few members there also jumped on the project, and we're now done with the design document. They're actually doing some code, so I'm pretty happy with that. Yeah, questions?
Okay, I have a question. If this thing was over here for around, what was it, like 10 years, right? So why wasn't it maintained? Because it's pretty interesting. There's a guy in jail already in England, as far as I know.
Yeah, so it was written by Julian and I think Ralph Reiner something. But those were pretty much the only two guys working actively on it. And Ralph pursued an academic career, and Julian is doing some other things. So I think that's the main reason it wasn't picked up. And the code base was very large and complex. And at this point, it doesn't make sense to pick up that work anymore. And might have been more sensible 10 years ago, but then I wasn't, yeah. I'm not sure why someone else didn't do it. But
Do you have to mount all the partitions at the same time in order to write large amounts of data?
Yes. I mean, depending on how much you pre-allocate, so you can say, hey, I want you to allocate some extra data, but at some point that might be not be very nice. But you can do it. But if you really want to write a large amount of data, then it's advisable to do it, because otherwise you'll probably lose a lot of data, depending on how large your hard disk is.
Can you mix and match with other file systems? Probably not.
Okay, so the idea is that we implement a block mapper and encryption, which means that you can put any file system you want on it. You can put ZFS on it, X3, X4, X2, etc. Was that your question?
Not exactly.
Okay, sorry.
Some other file system that looks legitimate and it looks like a simple user that's not using anything fancy.
The first part of the question, like the first 3 words, I didn't get them. Sorry.
So the basic unencrypted part of whatever you're using is unencrypted and looks like there's some simple user that's not doing anything fancy. Can you do that? Some part that looks unencrypted?
Yes. So you can partition your hard disk, like normally partition your hard disk in a root file system, and then have lots of random data next to it, which can be a source for Rubbernose. So that's perfectly possible. And just don't put it in your auto mining scripts, because then people can still see that you're using it. So yeah, that's something we'll figure out along the way.
Okay, thank you.
So it's worth pointing out that the mailing does in fact say Rubbernose. That's because whoever created the mailing list made a typo or a boo, and now the mailing list is called Rubbernose, but the RC channel and the website/wiki are called Rubbernose.
How do you compare Rubbernose to TrueCrypt or BestCrypt, for example?
It's a good question. So TrueCrypt has some feature of a hidden partition, but I think it only has one.
Well, they have hidden partition and hidden OS as well, and you can cascade those, as many times as you wish. So it's basically plausible deniability. It's not on the best level, because some forensics are gonna eventually unveil that you have some hidden data on the disk.
Yeah, so one of the ideas is that, so as far as I understood, TrueCrypt allows you to have like one or maybe a hidden OS and a hidden partition, but it's only one. And the idea is here that you can have like 20, and they'll contain some different information. This is just one partition, and you can say that you don't have it, but so I'm not sure how strong their plausible deniability is. I really can't comment on it. But we wanted something more than just one partition. And we wanted to do it relatively simple, which was doable with device mappers. That's why we went this way. And TrueCrypt is not very easy to send patches to and develop, because they're kind of closed in their development model. Other questions?
So if you have just one partition mounted, which is like 10 gigabytes in size, but your whole hard disk is, say, 200 gigabytes, wouldn't that be suspicious?
Oh, yes, but not really. I mean, I have quite a few hard disks that I've actually some random data in the middle because I fucked up during. I'm sorry, I fudged up during partitioning, and I didn't want to resize anymore because the fat file system doesn't support it or something like that. So that was it's possible, and still, I mean, it's not like even if you unlock 10 partitions and you have 20, it doesn't mean you need to use up all the data because generally you're not using up all the data, and it's just an effect of this file system that you can't see how much data is actually in use. And that on itself is not a reason to hold you. Shouldn't be, at least.
I have just two quick small questions. One is, you say that this thing works on Linux 2.2, which is quite old. Do you plan on porting this to the newest kernel version, or you're reviving the project? With
So Rubbernose, the old project worked on Linux 2.2, but we're creating a new system, and that will work on new kernels.
So you're not actually using the old code?
No, just their documentation and whatever they wrote, and seeing if they had interesting ideas and hints.
And the second, more non-technical question, you mentioned that a law is going to be passed in the Netherlands that you can be
Yes.
whether this applies to communication as well?
Oh, I don't. But the idea of the law is that they have laws that it applies to you. You can have an encrypted partition according to the law, but you should unlock it if they ask you to. So you can have an encrypted partition, but if they say show it to us, then you have to show it, and otherwise we'll put you in jail because yeah. I don't know if it applies to, say, PGP encrypted email, but I guess you can extrapolate to that point as well. But I don't know that. I guess it depends on what they want.
Are you working on ways to hide the existence of such random data inside the metadata of the existing ext4 or other popular file systems? To be able to deny that there is anything there.
That's not in this project. It's possible, but then you'd be doing more or less steganography, which is different from cryptography because you're just making it real hard to find the data, but you can actually access it quite easily. But no, that's not what we're doing.
From what I hear, you can position the data wherever you want, so I don't think it will be a problem to have, say, a fat partition with a few files and then have in the same space that the fat system resides in, to have your area over which you port your little regions of your system. So you can have a bigger file system on top of what you're doing, and given that you don't have files in it that take up the space which you use, you can
so you're suggesting to use an unencrypted file system to use its unused space for your partitions? Is that what you're saying?
Yes, for the encrypted part.
Okay, I think it will be quite hard to implement. Yeah, so you'd have to change the and you need to know the layout, and if it's spread randomly, then it's quite different. So it's not very easy. That's a possibility. Okay. Yeah, so then if you mounted read-only or never use it, then it's possible. Yep.
How about instead of any other partition, using something like a swapped partition that you never actually mount, so to say?
That's possible. So the idea is that it just looks like random data, which means you could also say it's just an encrypted swap partition. That's possible. Yes.
We are out of time, so
Okay. You can ask me a question outside.
yeah.
Thank you. Thank you. So if you have any other questions or you maybe want to work on a project, then let me know. Just send me an email or we can chat outside. Thank you.
И сега ще имам 15 минутна почивка.